Ladies and gentlemen, my name is Andre. I'm a postdoctoral researcher at Aalto University, and I will coordinate today's event. This event is kindly organized by Christina, Sara, and Otto. This event is brought to you by Aalto Center for Autonomous Systems, short ACAS. Please visit ACAS website for more information. And today we're talking about the autonomous driving. Let me introduce the speakers. First talk is a group of speakers from Sensible 4, and all of the speakers are graduates from Aalto University. Virve Leino, Technical Project Lead, Tuomas Sauliala, Technical Marketing Manager, and finally, Antti Kangasräisyö, Head of Research. Sensible 4 is a successful and very ambitious research-driven startup. They know about autonomous driving more than anyone else because they challenge harsh weather conditions. Their talk will be about state of autonomous driving. The history of self-driving in Finland will be presented. It also includes state and future opportunities for this ambitious area. Also, they will elaborate on cooperation opportunity between universities and industry. Second speaker is Professor Ville Kyrki from Aalto University, professor at School of Electrical Engineering and the head of the Intelligent Robotics Group. His main research interests are intelligent robotic systems and robotic vision. His talk will be about AI challenges for autonomous cars. Machine learning and other artificial intelligence methods are an essential part of autonomous driving software stack. He will speak about the challenges these AI methods face these days. Please, people from Sensible 4, the floor is yours now.
Okay, hello everyone. My name is Tuomas Sauliala and I'm starting my presentation here if I manage. Okay, cool. Here we go. So my name is Tuomas Sauliala. I come from the Sensible 4 as mentioned. The presentation topic for today is state of autonomous driving. With me I have Virve Leino and Antti Kangasräisyö here with, as mentioned. They'll be having their talks within some minutes also. What we have for it as an agenda. Well, first of all, I'm going to tell you who we are, the Sensible 4 as a company, where we come from, something about our history. Then Virve Leino will discuss the actual product, what we actually do here. And then I'm going to tell you briefly how we see the future of autonomous driving globally and here in Finland locally. After me and Virve, we have Antti Kangasräisyö, a doctor of science from Aalto University, discussing the actual science of autonomous driving and what the university and industry may be doing together in the near future. Some words about myself. As mentioned, I'm Tuomas. I have done my studies at Aalto University, which was then known as Helsinki University of Technology. My department was electrical engineering, but after the school, I've been mostly working with communications and marketing activities in Finnish IT sector, automotive and electric engineers. Electric engineering, put it that way, and electric vehicles. Then about the Sensible 4, who we are. Sensible 4 is a relatively young startup company. We're only 3 years old. The company has been founded 2017. When I joined this company last February, like 8 months ago, we had less than 30 people working at Sensible 4. Now we're 95. So the growth has been, should I say, fast. The roots of our company are deep in Finnish science and research, mainly at Aalto University. I'll discuss that a bit later. Considering the growth we have had, I'm very happy about it, considering the tough times we have right now with COVID-19. Sensible 4 is a software company. We use sensors. We build cars for our own product development, but at the end of the day, we are a software company. We don't make sensors. Virve will tell more about the actual product briefly. I'd like to highlight our pilots. With the pilot, we mean our vehicle driving there on a public road with real passengers. We have had multiple pilots in Finland, at Hämeenlinna, at Espoo near the Nokia headquarters, at Vantaa, and last spring we drove at Helsinki, Pasila area, so-called Fabulous Pilot, a European Union project. This year later, we're heading abroad with our first pilots in Norway, near the Oslo capital region, and then near the city of Stavanger, western Norway. I'm really looking forward to these two pilots. Later, maybe next year, maybe later, we're opening even further pilots in Japan, in Dubai, and in a European country. Next, I'd like to discuss something about the early days of autonomous driving in Finland. As mentioned, we actually, at Helsinki and in Finland, we have long roots of autonomous driving research. Already in 1980s, when I was born, the very first robots were researched at Otaniemi area at Helsinki University of Technology. These vehicles, these self-moving devices, are the very root of Sensible 4 and our current status of our products. I'd like to show you this one. Let's see if I can mute it. This one is driving 1993. You can see the vehicle is super slow, and the devices or the sensors on top of the vehicle are quite big compared to the ones we have right now. But still, this vehicle drove long before the Google was even invented or the DARPA project started in US. Another project, which I can show you, is this one. This one drove 2007. You can already see that the sensors are way smaller, pretty much the size we have now. The vehicle is moving faster, and there really is a bad weather right there. This is actually taken at Helsinki. It doesn't look like capital, but that's what it is. So even though our company is only 3 years old, we have a long history of research in Finland regarding self-moving vehicles and robots. And for the next speaker, I'd like to invite Virve-Leino, please, about the driving kit.
Okay, and thank you, Thomas. Nice to be talking to here in this ACAS event. So, my name is Virve-Leino, and I'm graduated from Aalto University, as many of us here at Sensible 4 are. And I was majoring in software engineering and so, yeah, computer science. For the last years, I have been working in autonomous driving industry, first in California and then in Sweden, Gothenburg, and currently happy to be working at Sensible 4. So my topic today is our product. So what we do, our product is autonomous driving kit. And to start on a high level, if we think about building an autonomously driving vehicle, I think it's basically a robotics problem. So what I mean by that is that first the vehicle needs to sense its environment, and it's using multiple sensors to do that. Then the vehicle is thinking, processing this data it's receiving from the sensors. And third, it's using actuators to actually drive on the road. At the Sensible 4, we are doing the thinking part, this Sensible 4 autonomous driving kit. But if we start taking a more closer look at the sensors first. So first, there are these kind of line of sight sensors, LiDARs, radars, and cameras. And those sensors are perceiving the world around the vehicle. Perhaps some explanation about LiDARs if someone is not familiar. So LiDAR is 3D image, how to say it, light imaging sensor. Yeah, it's sending actually light beams. Multiple of those might be like 42 light beams, for example, and those light beams are going around the sensor 10 times per minute, and the LiDAR is producing a 3D point cloud from that data. Then if we take a look at the other type of sensors, there are these kind of like position related sensors. Some examples are GNSS, so global navigation system. For example, GPS is that kind of measurement. Then we have RTK, real-time kinematic, and that we are using, for example, at Sensible 4 to make the location more precise. And then there are other sensors, position-related sensors as well. IMU, the inertial measurement unit, and odometry. So, for example, wheel odometry, measuring how many times the wheels are spinning around. If we then move to our software, so in addition to these typical sensors, you can also think that there are other kind of sensors. The software is using map, and then our software is knowing the route, or then it can get the route from the remote control center, and it can also receive other kind of commands from the remote control center. And the last step is actuators, steering, braking, and throttle. That's very familiar to all of you. So let's take a closer look at our software kit. It actually contains of 4 parts. First, there is this position stack. The main target of this stack is to know where the vehicle is located. Then we have obstacle detection, detecting both these kind of like moving objects and also like stationary objects, and making sure that the vehicle is not colliding with these objects. And then at the end we have control stack. The control stack is then doing the final decisions regarding the path the vehicle is taking, and then controlling these actuators. Then this box on the top of these three stacks is remote operations and fleet management APIs. So API is application interface, and we are concentrating on building mainly the application interfaces, and we prefer third parties to do actual remote control operations and fleet management. In some cases, we have been also doing the remote operations ourselves. And in very top of this picture, you can see the apps for travelers. So by that I mean this kind of like apps, phone apps, for example, that travelers, so basically all citizens can then use to order these trips from these shared, most preferably electric shared vehicles and autonomously driven vehicles. Okay, that was that on paper, but let's now check how this kind of like autonomously driven vehicle might look like. This is actually our first autonomously driven vehicle. It's called Judo. We always give names to these vehicles. The vehicle itself is produced by Renault. It's this kind of mini vehicle, electric and 2-seated. And actually the model name is called Twizy. But then what we did at Sensible 4, we actually made this Twizy to drive autonomously. And there is actually a term for that, so it's retrofitting. And in this retrofitting process, so first step is to add these sensors to the vehicle. Then we added a computing platform and our self-driving kit. And then we, as the last step, connected that self-driving kit to actuators with drive-by-wire. And drive-by-wire system is this kind of system that you can use then software to control the actual actuators, so steering and braking and so on. So Small explanation about these sensors. What we installed to this Judo are LiDARs, for example, one in front and one in the back of this vehicle. You can see those, one LiDAR, for example, near the front lights. Then we had short and medium range radars. And you can see radars between the middle front wheels there. Then we like to have 360-degree camera system because that's very handy when we take over the control from the remote control center. And then we also tested thermal cameras. Thermal cameras are very handy in the dark environment when you can see warm objects. So, for example, you can sense the pedestrians. For positioning, we used RTK and GNSS, and those you can see on the top of the vehicle. And also IMU is inertial measurement unit and odometry, those are inside the vehicle. And last, there was this 4G, 5G connection, and that we need when we are taking over in some cases with the remote control center. Okay, so I guess it's interesting to see how this driving actually looks like. So let's take a look at one of our demonstration, which is actually in very harsh winter conditions, and that we are actually very proud of. So it's recorded already 2.5 years ago at Otaniemi, where our roots are in many kind of like from many point of views. Our founders are from Otaniemi. Many of us have been studying at Otaniemi and Aalto University. Of course, we then have many employees coming from all around the world, like at this time, I guess 20 countries where our employees are from. But this demonstration is about winter driving and SLAM, object detection and localization. But let's start the video and I'm explaining as we go. Okay, I guess it's here, and let's hope that starts. Waiting some seconds. What do you think, Tuomas? Is the video starting? Do I need to push something? Okay, just a minute. Okay, and here we go. Okay, thank you, Tuomas. Okay, so this is about winter driving, actually at Otaniemi. And as you can see, the lanes were really invisible, and the weather was just like awful. Yeah, that was good winter to test our vehicles. Okay, there the Judo is driving, and on the right hand upper corner you can see the LiDAR in the same way as Judo is seeing it. And it's able to keep the lane very well already at that time. The next demonstration is about SLAM. So this kind of like simultaneous localization and mapping. In the screen you can actually see the map, and it's actually the vehicle is building the map at the same time as it's driving. In our case, it's updating the map as the map has been already given to it. It looks perhaps a little bit funny, but this is actually very good way of doing the localization. And then one of the cases was this obstacle detection. Our vehicles are of course using other sensors as well. In addition to this LiDAR, they are using cameras and radars. And now Judo was able to yield these pedestrians quite nicely. And it's due to the fact that it can understand what all objects are stationary and which objects are moving objects. So it's then extra careful about those moving objects. And last demonstration is about this localization. So how this vehicle is actually able to keep its lane. So it's comparing its LiDAR cloud, which you can see in the screen, to this NDT map, which is on the right-hand upper corner. So this kind of like normal distribution map. And by comparisons, it can understand where it's going, and that's very exact. I would say that it's more exact, you know, if you compare to human drivers. So this is, yeah, nice. And there are some pictures about Judo after the winter driving case. Okay, but that's all from my side. Then I guess it's Tuomas, your turn again. Yes, please.
Thank you, Virve. Next, I'd like to discuss briefly about the future of autonomous driving, how we see it at Sensible 4. I have only one slide, don't worry, this won't take too long. There are a couple of angles which I'd like to bring out with this topic. First of all, we don't believe that we are going to have fully autonomous, so-called level 5 autonomous vehicles with zero assistance from a human being anytime soon. I would say it will take years or maybe even like decades to develop such a vehicle. The future of autonomous driving will most likely happen on restricted areas, on predefined routes, in so-called restricted operational domain, when we can set the rules of driving a bit, should I say, narrow compared to fully autonomous driving. The sensor stack, the computers, and maybe the software will cost some money. So it's quite clear that the use case of autonomous vehicle will be somewhere where the need is big and the predefined routes are already existing. So it's quite clear that the very first commercial applications will be public transportation with the last mile shuttle bus application. And for us Finns, it's quite clear that the vehicles need to be able to drive in all weather conditions. In Finland, we have at least 6 months a year, really bad weather, rainy, slushy, maybe, hopefully we have snow. Whatever vehicle we have, whatever the public transportation solution it's going to be, it needs to be able to drive in all weather conditions. And when it's not able to decide if the vehicle can go forward or if it needs to change the lane or something like that, it needs to have functional and working remote assistance when needed, or remote control if you want to call it that way. In this sense, I believe that autonomous vehicles will not enter in normal passenger car world anytime soon. It's going to be professional and commercial application for sure. Okay, this is end of our first section. Do we have any questions at this point?
Yes, Thomas, thank you very much for your first part. We already have a number of questions, so I think we can take a short time to answer those questions. So the first one, did you develop the remote control center, or did you give some cloud robotics platform like Freedom Robotics a try?
Well, the answer is, would you like to answer or?
Yeah,
okay.
I can of course start. So yes, mainly we believe in doing and building things together. So that's why we like to work with partners. So mainly in remote operations, we are concentrating on doing extremely high quality application interface. so that we can work with partner companies. We also have an implementation of this remote operation center ourselves, and we are of course testing with our own implementation and so on, but at the end we would like our partners to do that part. This company that was mentioned there, we haven't tried out their solutions, but for example we are working with, I guess I can say this, Holo. We are working with Holo, which is one big operator in Nordics. So we believe in collaboration there. Yes.
Thank you.
Yes. Thank you. Yes.
The second question: what is the speed limit for Judo?
As far as I know, it's 40 kilometers per hour right now. It's actually the speed limit of all our vehicles right now, 40 kilometers or 25 miles per hour.
Yeah, and I can also add to that we have been driving and testing like a little bit faster as well, but of course it's not safe to drive super fast. But of course we are trying to push the limits of these vehicles and testing what they are capable of. But this kind of like 40 kilometers per hour is based on current understanding the very good speed to drive with our vehicles. And that's this kind of driving that we are kind of like now focusing on. We are not focusing on highway very fast speed driving, but we are mainly focusing on this kind of like shuttle bus and providing this transportation for cities. Citizens of cities and citizens. Yes.
Next question, in the quotes, I understand that you also did a cooperation with Nokia to deploy 5G for autonomous driving. Could you describe about your partners and customers?
Well, once again, would you like to do that? Maybe you should take care of this.
Yeah, I don't know about all of our customers. It's kind of like under NDA as well, but we have many customers and are doing multiple pilots, and Nokia was mentioned there. So Nokia is one of our partners, and we are doing, for example, project with Nokia. I guess this
related to 5G, I guess.
5G. I guess last week you were talking about this Lux Turim, for example, that kind of project that has these smart poles and this smart city infrastructure actually deployed at Karamalmi area. So actually we are part of that that project as well. And as Nokia is there, so the 5G is of course part of that project. And 5G is important for us because at the end, when we are doing this level 4 autonomous driving, we want in some cases keep the control to this remote operation center. And there, as I was describing, the vehicle has 4 cameras or 360-degree view, and we want that kind of information to go very smoothly and fast to the remote operation center and the remote operator to be able to handle the car. So that's why 5G and small delays in the network traffic and huge bandwidths are important for our operations.
Thank you very much. I think now we should switch to the second part of your presentation, and in case we have time left by the end of the second part, we will continue with the rest of the questions that we have had so far.
Yes, let's do like that.
Thank you.
Okay, thank you.
All right. All right, yeah. Welcome everyone to my part of the presentation. So my name is Antti Kangasraasio, and I'm the head of research at Sensible4. So like when you have gone to your local car dealership lately, you probably have noticed that you can't really buy a level 4 self-driving vehicle there yet, unfortunately. And I think one main reason for that is that there's still multiple problems, like research problems, technical problems that we still need to solve, or solve so reliably that we can actually trust that these self-driving vehicles can drive safely in all kinds of weather conditions and among human traffic. So in this part of the presentation, I'll quickly go through different research aspects that we have relating to self-driving vehicles. Unfortunately, due to the time, I can't go very deeply in any of the topics, but I can take some questions afterwards. All right. Yeah, so as you heard, we're building full stack software that enables all-weather autonomous driving. And now if we want to build a software like that, there's a range of problems that we need to solve, starting from planning and control. So thinking like, how should we control the vehicle in each kind of situations? How do we achieve tasks among traffic? Object detection and tracking, like how do we observe our surroundings? How do we keep track and predict what other traffic participants are doing? Positioning and mapping, how do we know where we are? How do we know like how to drive to remote locations, like using maps for that? Modeling and inference, so these kind of generic or more general scientific modeling questions, like how do we estimate different variables from data and signals and so on. We also need to consider things like performance evaluation. How can we guarantee that our solutions are safe and secure? And also problems, for example, with remote operation, how do we make that like cost efficient and feasible and so on. And I'll go next through each of these topics in a bit more detail. All right, and also like if you're interested in collaboration with any of the topics, let's talk later. So of course, this is like a wide range of problems to solve. Well, we already have like almost 100 people in the company solving these problems, but that probably isn't yet enough to solve everything perfectly. So of course, there's plenty of very interesting research going on in Finland and other parts of the world as well. So we're of course very interested in research collaboration that could benefit both us and then the researchers. And also like we are hiring later on. So if you are, let's say, looking for like a postdoc in a company position or research internship or something like that, keep us in mind. So first, let's go through quickly planning and control. So what do we mean by that? So planning means like finding an optimal reference path, given some kind of a cost function that defines what is the task that the vehicle needs to accomplish, and also some constraints that determine what the vehicle shouldn't do. Like we have various constraints in traffic, like all the traffic rules that we have to obey. There's all kinds of other vehicles that we cannot collide with, and we need to take all of that into consideration when we make a plan on, let's say, how do we navigate this roundabout intersection? Should we go now or should we wait a bit? Like what's our plan? How do we get those plans, and how do we solve those plans efficiently online? And then a related problem is the control problem. So once we have this plan, okay, let's wait for that vehicle, then go and turn left. Then how do we execute that plan perfectly, or at least last well enough to survive in the traffic? And here we need to take into account consideration like robustness. Perhaps the plan wasn't perfect. We need to make slight alterations to the plan. Maybe other traffic participants didn't behave precisely as we planned. So being reactive, being safe, like even when our plan isn't perfect and there's various uncertainties. And also there's different uncertainties for the environment as well, like there might be some black ice on the road that we didn't notice, and we need to react to that instinctively. Like once we realize that, hey, we're losing friction, we need to do something about this. And then there's of course this safety control aspect. So usually like these control methods, we might use a bit more advanced methods there. But the drawback with advanced methods is that it's more difficult to give like very high reliability, like guarantees to those. Like we might say that, okay, this works 99.9% of the time, but then like the legislator might ask, okay, so what about the 0.1%? What happens then? So the safety control is then like the really reliable, isolated way that we make sure that even though we use advanced methods for the routine control, we can still guarantee safety even in very spurious, strange situations that the vehicle might end up Then going forward, we have then problems like object detection and tracking, so understanding what's happening in the world around the vehicle. And here, interesting problems are, for example, detection. So there's all kinds of things happening around the vehicle. So how do we find out like which of these are interesting traffic participants that we need to consider, and which of these are just something like leaves flying in the wind or some birds that we don't actually need to care about. So finding these interesting objects and keeping them track of those. And then, of course, like once we find the objects, we might also need to do classification, so determining what kind of an object is this. Is this a vehicle? Is this a moving vehicle or a stationary vehicle? Is this a pedestrian? And so on. And then tracking, of course, so once we have identified that, hey, this is a moving vehicle, we might be asking, so where is that vehicle going to be in 2 seconds of time, in 5 seconds of time, in 10 seconds of time? So where is it going? Is it heading towards us? Do we need to avoid it? Or is it going away from us, so we don't actually need to care that much about the vehicle? And then there's all kinds of other aspects of like detecting environment, problems like lane detection. So let's say there's snow on the road, so how can we estimate which are the lanes that we're supposed to use, let's say for driving forward or taking a left turn, when we might only have very partial observability of what the lanes are. And things like free space estimation, like do we have space in here to make a U-turn, or do we need to maybe plan for another kinds of maneuver in this kind of situation. Then moving on, so positioning and mapping, I guess this is one of our, let's say, crown jewels. So we have maybe the longest history of research in this front. So here we have problems like, well, positioning. So answering questions like, okay, so precisely where the vehicle is, how is it oriented in the environment, what's our velocity relative to some map that we have. And this is of course very important. For example, if we have a predefined route that we need to follow, if we can't tell where we are, then of course we cannot follow that route either. And then a related problem is this mapping. So let's say that we have some environment that we haven't been before. So we are creating a map of that environment as we go along there, so that when we go there back again, we already know how the environment looks and we can do more efficient planning. And of course, there's problems like updating these maps. So you might make a map once, but then there's some road work and situation changes. So how do you update those maps reliably on the fly? Yeah, and yeah, as I said, challenges here are like that the environments change seasonally. So and we might have situations like we make a map in the summer, in the winter there's a lot of snow. So can we still use that map for navigation, or how can we use that map for navigation reliably even in winter? Then these more maybe fundamental like mathematical modeling problems, maybe more related to control engineering, for example. So we have problems like system identification and model calibration. So we have these nuanced models of how these vehicles behave, and then we want to do control engineering based on those models. But then we face problems like, how do we precisely set the parameters of those models so that our predictions are reliable? And how can we estimate time-changing state variables online reliably? And these might be things like how much friction do we actually have, like how slippery is the road, for example. How do we estimate that reliably online? Right. So that would be the state estimation problem here. And then, of course, like we want to drive in very different kinds of situations. So the environment is all the time changing. So it's very important for us to be able to estimate the uncertainty of our models reliably. So how much do we actually know of what's going on? What's our uncertainty? And then taking that kind of uncertainty into account once we decide what to do. Then, of course, performance evaluation, very important topic in guaranteeing that the solution that we build is actually reliable, it actually works, and we have tested it. So here we can start with problem or solutions like evaluation in simulation. So using various simulation environments to prove and test that our solution actually works. And then, of course, we get into these kind of challenges like simulator management. Let's say we want to have 1,000 simulations running in parallel and multiple people submitting different simulation experiments. So how do we manage all of this? And then we might also go into this hardware into loop simulation, where we use these more realistic or even like hardware parts as part of the simulation. So how do we set those kind of situations up? And of course, the most expensive, but also maybe the most relevant is these real vehicle evaluations. So driving with real vehicles in real roads, collecting data from there, and testing that our solutions actually work. And then, of course, we get also into these data management problems, like if we want to store all the data from one vehicle, it's about 1 terabyte per hour. And if we start to have like multiple tens of vehicles and they drive quite a lot every day, so how do we keep track of all this data? How do we select what data to store and manage all of this, like torrent of data that we can get from the vehicles? And finally, we can talk a bit about remote operation as well, although we're not doing it ourselves, but these are very relevant problems for us to understand. So for example, we have these remote operations. So how can we design our software so that we can support the remote operator workflow as efficiently as possible, so that one remote operator can easily manage a large fleet of vehicles and not be overwhelmed by all the kinds of decisions that the remote operator has to do. And also thinking problems like bandwidth adaptivity, like our vehicles might have to drive in different kinds of communication environments. So you might not have 5G everywhere, but maybe only 4G or 3G. So how do you optimize how do you communicate with the remote control center in different situations? All right, so to summarize this part, so full stack vehicle automation requires solving a wide range of technical challenges, which I've just given you a slight overview of. And keep in mind, like Sensible 4 is always interested in research collaboration, and will also be hiring next year. All right. So I guess that concludes our talk for today.